Vision on integration, okay? So let's start off really easy. Part one. Whatever the power is, add 1 onto it. So if it's x4, what are we going to end up with? x5. And then it's 1 divided by the new power, which is going to be 1/5 x to the 5 plus what, guys? Plus c. How would you check your answer? Differentiate it. When you differentiate it, it should turn back into the original x power 4. Second one, we really quickly. 3x4, integrate that. So remember, just ignore the 3. The 3 can almost be on the outside because it's a constant. Integrate x4 and we get x5 and 1/5 on the outside. 3 on the outside of that. 3 times 1/5, 3/5 x5. That alright? If you did, and plus c, because there's no limits. Okay, moving on. Differentiating. I had to get my integration tables out in a second because I don't know all these off by heart. Didn't see the point. I always get them confused with the differentiation anyway, so I never learnt them off by heart. So differentiate. We'll go straight for cos x dx. Now you look up your integration log tables, and what you find is that cos x changes directly into sin x. Because the angle is a 1x, there's nothing fancy to do here. However, when you're integrating cos 3x, guys, what about cos 3x? Key thing to remember about integration of trigonometric functions is that the angle never changes value. So it'll go to sin 3x. Now the part you're forgetting is what? Differentiate the angle. Whatever the answer is for the derivative of the angle, 1 divided by that answer. So 1 over 3 sin 3x plus c. Are we happy with that? Once again, just go back here for one more time. First things first, you identify what it changes into. Cos changes into sin. Angle remains unchanged. Differentiate the angle and put the answer underneath 1. 1/3 sin 3x plus c. Okay, let's try sin 4x now. Sin 4x dx, guys. Any guesses? Or sin turns into, so sin 4x turns directly into minus cos 4x. Differentiate the angle. What you get? 4, and then just divide it by 4, and you're done. Plus c. Okay. Next type is question 4. It's logs. Okay, log functions. Now, the way to do logs, I wonder if I can remember these ones. 1 over ln whatever is divided by derivative of what it is. Okay, so an example will be 1 over x. Integrate that. You check your tables. It will turn into ln x plus c. Is that okay? Now, to remember of how to integrate something that has a 1 on the bottom and the variable on the bottom. Sorry, 1 on top and the variable on the bottom. Here's what you gotta do. Okay, 1 divided by wherever is in this box. Okay, it's gonna be ln whatever is in that box. Yeah. Differentiate the box, and it's going to be 1 divided by the derivative. 1 divided by the derivative of the box, ln whatever is in the box, plus c. As an example, that's the rule for logs, integrating logs. Okay? So, what's in the box this time is the 2x plus 3. That means there's going to be a 2x plus 3 here. It also means we've got to differentiate 2x plus 3. What happens when you differentiate 2x plus 3? 2. So the answer is a half ln 2x plus 3 plus c. Would you like me to try one more of them? One more log question. I'll make up one. 1 divided by, I'll make it a bit harder, 3x squared plus 5. Okay. Same thing again. Okay. Uh, wait. I'll just get back my old 1 over 3x squared plus 5. Okay. Just 1 second. Integrate 1 over 3x squared plus 5. Okay, guys. 3x squared plus 5 goes here. That means it automatically turns into ln 3x squared plus 5. Differentiate 3x squared plus 5, and what you get? 6x on the bottom. Oh dear. Okay. 1 divided by 6x. So 1 divided by 6x ln 3x squared plus 5 in brackets plus c. Is that alright? Yeah. That is the normal way. Something like this, guys. If I had instead of one like this, if I had integrate 4 times 3x plus 5, something like that. What I can then change this question to is 4 times the integral of 1 plus 3x plus 5, and it's going to be 4 times the answer for the integral. Okay, what is the integral again? What did I say it was? ln whatever it is, it's 3x plus 5, and then 1 divided by the derivative of what it is. What it is the derivative of 3x plus 5 is, would you differentiate 3x plus 5? 3. 4 times the third ln 3x plus 5, 4 over 3 ln 3x plus 5. That right? Okay. Let's go a bit further. Okay, guys. So what we're doing next is integrating e to the 2x, e to the x. Okay. Does anybody in class remember what happens when you integrate e to the x? The answer is e to the x plus c. What happens if you integrate e to the 8x dx? ax plus c, and you have to put in a modification here. It's 1 divided by the derivative of the power, which is going to be 1 over 8 e to the 8x plus c. Everybody alright with that? Okay. It's handy enough. Next one, guys. Question 6 is your it's either sine inverse or tan inverse. Okay, so you look up your formula, and I think your formula is tan inverse x over a. Where is it? Is oh wait. It's the opposite way around. Excuse me. Anybody have the tables on them? We also have 2 preset formulas for e to the x. Okay, so what happens is sorry, for inverse functions. Okay, so the integral of a square root of a squared minus x squared equals sine inverse x over a. The integral of 1 over x squared plus a squared equals 1 over a tan inverse x over a. When I was in school, I actually found these ones the most difficult. The tan inverse functions I actually found the most difficult. Okay, so what we're going to do here is we figure out the a value and we figure out the x value. So in 6 part 1, you can say that it's 1 divided by the square root of 7 squared minus x squared dx, and that in turn will get us sine inverse x over 7. The second question, see that dx is on top here. Same thing as me replacing that with 1 and putting the dx at the end. 1 dx, okay? Excuse me. So guys, we get the square root of 100, so that's going to be 10 squared minus x squared, and that's therefore going to be sine inverse x over 10 plus c. Alright? Now, go to 7 part 1, 7 part 2. What we get here, guys? Okay. Sorry. Now, square root of 1 over x squared plus 5 squared dx. It's similar structure to the tan inverse one, so it's 1 over 5 tan inverse x over 5. And the second one's just going to be 1 over 25. Same thing. Everybody remember these, or have you done integration recently? Sorry? So once again, the last one here, you can slide the dx out. So it's 1 over x squared, square root 625, and you get 25 squared. And then you get the dx on the outside. Follow the function. A is 25, so it's 1 over 25. Tan inverse x over 25. Now we're forgetting the plus c's there, by the way. There you go. What did you ask me? So guys, what we're going to do next is we're looking at this one here. Now this one here is an interesting one. Any suggestions on how you might tackle it? Okay, and x over x. 1. Okay. Now, integrate 1 x. When you differentiate x, it becomes 1. And then differentiate 1 over x. And then x plus c. Okay. 1 over x is a preset in your formulas. No, because it's just never been done that way. Like even in your book, it's just now. We have next, guys, is it's going to be 1 divided by 1 over x plus 1. Now, Adam, this is one of these ones that has a number on the top and it has the variable on the bottom. This means that it has to be done using ln. Now, the only thing that it tells you about ln in this is that only thing that it tells you to do when you integrate it, it's going to tell you, oh, the answer is ln whatever is on the bottom plus c. But what's omitted in your papers is it's 1 divided by the derivative of whatever was on the bottom. That's omitted from your log table, so you have to remember that. Okay, lucky for us in this particular example, the derivative of 1x plus 1 is in fact 1. So don't really need to pay much attention to it there. Then it's just ln x plus 1 plus c. Alright? Now, how are you going to do the likes of question 9 is ridiculously easy. Question 9 part 2. 2x plus 1 to be squared dx. Is there some form of chain rule for this? Just square it out exactly. 4x squared plus 4x plus 1. Integrate it. X cubed divided by the new power 4 over 3 x cubed. X squared. What multiplies by the 2 to give you 4? 2x squared. Then 1 turns into x, and then there's a c at the back. Any questions? We're going to do next, guys. Finally, last section. Integral of 1 over 5x plus 1 dx. There's something on the bottom. Okay? It's a log function. ln 5 plus x. 1 divided by the derivative of that is 1 over 5 ln 5x plus 1 plus c. Now, this one here, Adam, because it's not minus 1, we're allowed to do it. Okay? So it's going to be integral of 1 divided by x to the power of a half. That in turn is the same thing as x to the power of minus a half. It now qualifies under the original rule because it's not n equals minus 1. So what we can do here is we can say add 1 onto the power, isn't it? So x to the power of a half. 1 divided by your new power is 1 divided by a half. What's 1 divided by a half? 2. So it's 2x to the power of a half plus c. If you aren't sure, differentiate it. A half multiplies by 2 to become 1. Take 1 away from the power. X to the power of minus a half. Brings you back to where you began. Okay, how am I